All right, this is Chapter 5, Lesson 2, Sequence. So we're going to be talking about sequences today. So there's actually two different types of sequences that we're going to be talking about. One's more prominent than the other. So we're going to be talking about geometric sequences, which usually deal with multiplication. And then we also have arithmetic sequences, which is what's more common, and it's, a lot of times that's what we'll be using in our math course. Okay, so arithmetic sequences are just dealing with addition. So it's just finding that pattern. Okay, that's basically what a sequence is you're finding a pattern. Okay, so a blank is an ordered list of numbers. Each number in a sequence is called a blank. So in those blanks, you're going to write sequence and term. Okay, so a sequence is an ordered list of numbers. Each number in a sequence is called a term. In a blank blank, each term is found by adding the same number to the previous term. In those blanks, you're writing arithmetic sequence. Okay. So an arithmetic sequence deals with arithmetic. It deals with adding. Okay. So you're adding each term every time. So arithmetic adding. Okay. So we can describe and extend sequences. So in an arithmetic sequence, the terms can be whole numbers, fractions, or decimals. So let's look at an arithmetic sequence. I want to continue the sequence 1, 3, 5, 7. Well, each time I'm adding 2. So 1 plus 2 gives me 3, 3 plus 2 is 5, 5 plus 2 is 7, 7 plus 2 would give you 9. How about for 1, 1.5, 2? I need to come up with the next three numbers in the sequence. Well, 1 plus 0.5 gives me 1.5. 1.5 plus 0.5 gives me 2. 2 plus 0.5 gives me 2.5. Plus 0.5 gives me 3. And plus 0.5 gives me 3.5. So each sequence I'm adding 0.5 to the previous term. Okay, so for my first term, I was actually adding 0, and for my second one, I'm adding 0.5 to each term. So for the first sequence, I added 2, and for the second sequence, I add 0.5 to each term. Okay, describe the relationship between the terms in the arithmetic sequence. 8, 13, 18, 23, and the ... means it goes on forever. Then write the next three terms in the sequence. Each term is found by adding what to the previous term? 5. So I add 5 to each term. So 23 plus 5 gives me 28. 28 plus 5 gives me 33. And 33 plus 5 gives me 38. So the next three terms are 28, 33, and 38. All right, we've talked a little bit about writing an algebraic expression. We actually talked about this a little bit last lesson. So in a sequence, each term has a specific position within a sequence. So consider the sequence 2, 4, 6, 8. You're going up by 2 each time. So my first position was a 2. My second position is 4. My third position is a 6. And my fourth position is an 8. Notice that as the position number increases by 1, the value of the term increases by 2. So I start here at my first position. I go up 1 position, my value increases by 2. Now I have 4. Okay? I go up by 1 position to third, my value increases by 2, so I have 6. I go up 1 position to fourth, my value increases by 2, now I have 8. Okay. So we get this. My first position, 1 times 2 gives me 2, so I have a value of term 2. Position 2, 2 times 2 gives me 4. Position 3, 3 times 2 gives me 6. Position 4, 4 times 2 gives me 8. You can also write an algebraic expression to represent the relationship between any term in the sequence and its position in the sequence. So in this case, if n represents the position of the sequence, the value of the term is 2n. So anytime I have position, so my fourth position has a value of 8, because 2 times 4 gives me 8. The greeting cards that Meredith makes are sold in boxes at a gift store. The first week, the store sold 5 boxes. Each week, the store sells 5 more boxes. The pattern continues. What algebraic expression can be used to find the total number of boxes sold at the end of the 100th week? What is the total? Okay, so it's asking me a couple of things. It's asking me first to find an expression and then to find for the 100th week. So, my first position, they sold 5, right? They sold 5. Every week after that, they sell 5. So my arithmetic sequence goes up by 5 each time. So my value, my term goes up by 1. My term each goes up by 5. The position number goes up by 1. So in the first week, they've sold 5 boxes. In the second week, they've sold 10. 2 times 5 gives me 10. Third week is 15. Fourth week is 20. So each term is 5 times its position. So the expression is 5n, where n represents the position. Okay? So that means my expression is 5n, and then I'm going to replace n with 100. I'm going to substitute that value in because they asked for the 100th week, if this pattern continues. So 5 times 100 is 500. So at the end of 100 weeks, she'll have sold 500 boxes of gift cards. All right, there's a couple try problems out below. I want you to go ahead, pause the video, try it out. When you're done, we'll go over the answer together. All right, now that you've had a chance to try out the try problem, let's go over the answer together. So my try problem states, describe the relationship between the terms in each arithmetic sequence. Then write the next 3 terms in the sequence. So I have 2.5, 3.0, 3.5, 4.0. So I can see that this is going up by 0.5 each time. So I can see that it goes up by 0.5 each time. So I'm going to add 4.0 plus 0.5 gives me 4.5. 4.5 plus 0.5 gives me 5.0. 5.0 plus 0.5 gives me 5.5. All right, the pattern shows 3 circles, 6 circles, 9 circles. What algebraic expression can be used to find the number of circles used in any figure? Okay, so we don't actually have a figure drawn for us. We can draw it ourselves. So the first one I would have is going to give me 3 circles. So 1, 2, 3. So that's my first one. My second one's going to be 6. My third one's going to be 9. So each time, so this is position 1, position 2, position 3. So each time I go up by 3. So each position I go up, my term goes up by 3, because 3 plus 3 gives me 6. 6 plus 3 gives me 9. Sorry, that's 7. There, 9. Okay, so I'm adding 3 each time. So that tells me that my algebraic expression is 3n, where n represents the position. Okay, so n equals the position. And I want to know how many circles will be in the 50th figure. So 3 times 50 equals 150. So 150 circles will be in the 50th figure. And that is the end of Chapter 5, Lesson 2.